Now that's it for this introduction to class-based components. I showed you that they exist, how they work and how you write your own ones, how you work with props and the render method, how you work with state, and also how you work with these lifecycle methods for side effects. And we also had a look at how you use context. You can build your entire application with class-based components if you want to. That is absolutely fine. And in the past, as I mentioned, you had to use them in some cases. But in modern React apps, you typically stick to functional components instead, simply because they are leaner and more flexible, as you learned throughout this module. That's why I also started with functional components in this course now, because the React ecosystem transitioned to functional components as the main thing, and that's why I focus on functional components in this course. Also going forward, for the rest of this course, functional components will be the focus, and I will only occasionally show you how to work with class-based components. Nonetheless, I want to emphasize that you don't have to use functional components. It is fine to use class-based ones if you prefer them. But chances are that you also see the benefits of functional components, and therefore it is fine to generally ignore class-based components, with one exception to which I'll come back to in a couple of minutes. Now, if you're not sure which approach to use, if you're not sure whether you want to go with class-based or functional components, here's a little helper decision tree, if you want to call it like that. As a general rule, you should simply prefer functional components. And you should instead use class-based components if you personally prefer them. So if you disagree, if you like them, of course you can use them. There's nothing wrong with them. If you're working on a project or in a team where there are a lot of class-based components being used, you might not have a choice then, and you might be confusing your colleagues if you start working with functional components only. And you also should use, and you must use, class-based components if you're building error boundaries. Now that's something we haven't learned yet, but that's exactly what we're going to take a look at in the next lecture now. Let me introduce you to error boundaries. Sometimes something goes wrong in your applications. And I'm not talking about bugs you introduced as a developer. Of course, you should simply fix them. But sometimes there are errors which you can't prevent or which are simply being used to transport information that something went wrong from one part of the application to another part. Consider an HTTP request which is being sent. If the server is temporarily not responding, the request can't complete, and you will likely end up with an error being generated in your application. Now, there is nothing you can do about that as a developer. Servers can be offline, and there are, in general, errors which can't be prevented. Here, I built a little dummy example. In the users component, I added the component did update lifecycle method. And in there, I check if my users prop, which I'm getting, which is an array of users, has a length of 0, which means there are no users. In which case, I throw a new error. And that is, of course, a technical thing in JavaScript. By doing this, by executing this line, I'm generating an error, and I let this error bubble up the call stack. So I pass it through all these components, and if it's not handled anywhere, this will crash my application. And you can see this if you add this code, if you run your application. As long as there are users, everything is fine. But if I search for something which is not part of any username, like an S, this will crash. And it crashes with the error I specified because it's my error which is not being handled. Now, of course, I could just simply not throw an error, but instead handle this case differently. But it's also quite common to use errors not as a bad thing, but simply as a way of transporting the information that something went wrong from place A to place B in your application. You can learn more about that, by the way, learn more about embracing errors in my clean code course if you want to, but that's just a side note. So here I generate an error and I want to generate an error. Of course, I don't want the entire application to crash. So what can we do? In regular JavaScript, we use try catch for this. We can try some code which might fail, and we catch potential errors when that code executes to then handle that error and run alternative code. That's what we can do in JavaScript. And with React, of course, we are just writing JavaScript code. Nonetheless, if an error is generated inside of a component and we can't handle it in that component though, let's say we don't want to handle this error in the user's component, but in a parent component instead, then we can't use try catch, because that only works in places where we write regular JavaScript statements. And if we throw an error and we want to handle it in a parent component, our problem is that in this case here, the user's component is generating that error, but that is not a regular JavaScript statement here. Instead here, we have JSX code, and the error is generated inside of that JSX code, inside of the user's component. Now we can't wrap this JSX code with try catch. Something like this doesn't work. So that's not an option. Instead, in such a case, you can build and utilize an error boundary. And that's what we're going to do now. For this, I'll add a new component and I will name it error boundary, though the name is up to you. It doesn't have to be named like this. It's a JavaScript file, and in there I will create a regular component, which I'll name error boundary. So let's import component from React, because I will build it as a class-based component, as you can already tell, like this. And now in there, I'll do something special. The error boundary component is a regular class-based component, but it is a class-based component which implements the component didCatch lifecycle method. The component didCatch lifecycle method can be added to any class-based component, and whenever you do add it to a class-based component, it makes that class-based component an error boundary. It's just a term which we use to refer to when we talk about components that have this lifecycle method. You can't add it to functional components, and there is no equivalent for functional components at the moment. So if you want to build an error boundary, it needs to be a class-based component, and then it is a class-based component which implements this lifecycle method. Now, what's the special thing about this lifecycle method? Well, this lifecycle method will be triggered whenever one of the child components throws an error or generates an error. Therefore, what we do in the error boundary as well is we add a render method, like in all components, and we return this props children. And that's special now. Here I return this props children because I want to wrap my error boundary component around components which should be protected by that component. So here, for example, in the user finder, I could wrap the error boundary around my users component. Of course, we now need to import it also. So we import error boundary from error boundary. And then we wrap it around any components which might throw errors which we want to handle. And of course, you can wrap it around more than one component. It's totally up to you. Now back to the error boundary. In there, or in this file, I of course also want to export error boundary. But then inside of this class, I now want to do something when an error occurs. For that, we get the error object here as a parameter automatically passed in by React. And we can then, of course, look into that error to find out what went wrong and maybe run different logic based on different errors. Though you could also consider creating different error boundaries for different errors. But then, of course, we can do whatever we want to do because it is a regular class-based component in the end. So we can also add a constructor called super and then set our state equal to has error false, for example. And that's totally up to you. It doesn't have to be named has error. You can manage any state you want here because it is just a regular class-based component in the end. But then when we catch an error here, we can call this set state and set has error to true. And then in the render method, we could check if this state has error is true. And if that's the case, we return something went wrong, like this. And that's how we could handle the error. We can, of course, also log the error or send it to a server for analytics or whatever we want to do. But now with that, we built an error boundary. And here's the result. If I now reload this, if I now enter an S, you will see something went wrong. Only briefly though, and then we see this screen again. Now that's only a development thing though, as you can also tell by the message down there. This is still shown by the React development server here in the end to make it clear to us that an error did occur. If you build your application for production and deploy it, something we'll also do later in the course, of course, this would not be visible. And you can close it here as well, this overlay. So this is what you would have in your real app, in your production app, without that development error message. And therefore, here we can see that the error boundary does work. Of course, it's unstyled because I haven't added any styling here to my error boundary, but you could do that. And the idea behind error boundaries really is that you can ensure that not your entire application crashes if something goes wrong, but that instead you can catch those errors and then handle them in an elegant way, just as you would do it with try-catch in regular JavaScript. And for error boundaries, if you add them, you need class-based components. This is currently not possible with functional components.